Dear students, I am very sure that this first week content will kindle your interest in the subject and you will start liking quantum mechanics. Dear students, I hope you had a great learning week. Before concluding this week, let's briefly revisit the important conclusions. First of all, please remember that quantum mechanics is the greatest intellectual development of the 20th century. We also noted that quantum mechanics originated from the failure of classical mechanics to explain various experimental phenomena such as blackbody radiation, photoelectric effect, Compton effect, and so forth. From all this, it was established that matter as well as radiation have dual behavior. That means both particle as well as wave character. Quantum mechanics is basically a theoretical science of microscopic matter. Why we need a separate science for microscopic matter is because of the fact that for microscopic matter, this dual behavior is very, very important. We also learned that quantum chemistry is nothing else but the application of quantum mechanics to three fundamental problems of chemistry, namely structure, bonding, and reactivity. We then basically moved on to the fundamental equation of quantum mechanics, that is the time-independent Schrödinger equation, that is h cap psi is equal to E psi. We discussed the various terms present in this equation. We saw that h cap is the total energy operator, E is the total energy value of the system, and psi is the wave function of the system. We then very briefly discussed the various steps which are involved in the solution of time-independent Schrödinger equation for any system. These four steps include, first is writing the Schrödinger equation for the system under consideration. Second step is defining boundary conditions for the system. Third is solution of Schrödinger equation. And the last step is extracting information out of psi. This psi comes from the solution of Schrödinger equation. Psi is the most important quantity in quantum mechanics, and as I mentioned it earlier, it is called the storehouse of information. However, this psi should satisfy certain conditions, and those are that it should be single valued, it should be continuous and doubly differentiable, finite, it should satisfy boundary conditions, and then it should be normalized. Now, with all what we have learned now, we are fully equipped to go to the next step. With this background of quantum mechanics, we will talk about the role and significance of operators in quantum mechanics, followed by the application of quantum mechanics to solve the problem of particle in a box in the coming week.